need a hug.
Okay, minasan, konnichiwa. Zamurai Engineer desu. Let us confirm if the sound is clear. Please. Okay, so let's proceed to our discussion on mechatronics engineering. So today we will talk about the component, electronic component, which is digital electronic component that is a popular go-to part when dealing with problem-solving solution for a mechatronics project or mechatronics problem. Okay, so this is the Arduino. So Arduino is a micro controller. So it is a microprocessor based microcontroller. So it has the all the parts that could make up a real computer, but very basic form and very minimal amount of capacity compared to computer itself, or compared to full-blown computer. And because of this, it may not be able to tackle the problems that could be solved by a computer, desktop, laptop, for example, but it is powerful enough to solve most of the real-life problems in instances of opportunity for a mechatronics application. So with that, let's proceed with our discussion. So we have here at your screen, in front of your screen, Arduino Uno. So there are several Arduino products. So Arduino Uno is one of them. It is a platform. It is a platform for controlling of input and output and motors. Okay, so in its basic form, it is a very small physically, about this big. Okay, so in your screen you have the latest version of Arduino Uno, which is the release 3rd, so release number 3. So in your screen you have the front side of the release 3 and the back side of the same board. Okay, and the previous one is Arduino Uno release number 2. This is the front side, Arduino Uno SMD. Okay, and Arduino Uno front, Arduino Uno back. This is the original Arduino Uno release, the first release, okay, the original release. So there is very minimal changes, but an important one. So let us talk about this. We have an overview of what really is Arduino Uno. So Uno, as in our country, it is a word which means one. Okay, so it is also an Italian word which means one. So Arduino Uno is a microcontroller board based on 80 mega 328. Okay, it is a 14 digital I/O pins, okay, of which 6 can be used as PWM. So PWM meaning pulse width modulation outputs. So because of pulse width modulation output, it could control, for example, stepper motor. Could control stepper motor with that kind of output. Okay, or because it produces pulse. Okay. Analog, 6 analog inputs, a 16 megahertz ceramic resonator, so the clock speed. Okay. A USB connection is available in order to be connected to a power source, or it could also be used as the connector for a laptop or desktop that could create the program that must be uploaded to the microcontroller board. Okay. So there is a specific language that the microcontroller board could understand. That's why we need to program it, for example, in a laptop, and upload it on the board in the appropriate form. Power jack is also available, which looks like the laptop jack. Okay. An ICSP header and a reset button. It also contains everything needed to support the microcontroller. For example, simply connect it to the computer with a USB cable, or power it with a AC to DC adapter or battery to get started. So simple as that. Very simple features, but the Uno differs from all preceding boards in that it does not use the FTDI USB to serial driver chip. Okay, so there's no FDTI USB to serial. It has the serial communication capability using the receive and transmit pins. Okay? Instead, it features 80 mega 16U2, 80 mega 8U2 up to version R2. Okay, so now it is 16, so it's 16 bits programmed as a USB to serial converter. Okay, so that is its way to be able to communicate using serial protocol. Okay, so revision 2, meaning R2, okay, of the Arduino Uno board has a resistor pulling 8U2, okay, HWB line to ground, making it easier to put into DFU mode. So as very small but convenient way to upgrade. Okay, very convenient way to upgrade. So just have the provision for line to ground. Okay, resistor pull. Okay, resistor pulling. Okay, so it's very convenient because we usually use the resistor pooling, for example, voltage divider. Okay, such in a way that we don't need to waste all of the time and energy and effort to just to interface it to a certain output. Okay, that is not exactly the level of the output of the Arduino signal. Okay. So what about revision 3? The board has the following features. So remember, Arduino original is all about this one. Okay, 14 IOs, 6 analog, 6 PWM, 16 megahertz. Okay, so microcontroller with this button. Okay, USB cable. But we have feature for revision 2 and for revision 3. Number 1, 1.0 pin out, added SDA and SCL pins that are near to the RF pin. Okay, there is an RF pin located somewhere near the reset button, and 2 other new pins placed near to the reset pin. That is the reset pin. Okay, the I/O RIP that allow the shields to adapt to the voltage provider from the board. So shields. So shields are also provided by the same or by as a product. Shields are provided as product to be able to easily integrate to Arduino I/O. Okay. So shields. In future, shields will be compatible both with the board that use the ABR, which operate with 5 volts, and with the Arduino Uno that operate with 3.3 volts. So there are actually two voltage levels currently being used by Arduino Uno. Okay. So Arduino Uno is 3.3. Okay. ABR is 5. So somewhat inconvenient when you take a look at it. You will have to really use the voltage divider circuit. The second one is a not connected pin that is reserved for future purposes. Okay, so that those are the added pins. Okay, another added feature is the stronger reset circuit. Okay, another one is the at 80 mega 16U2 replace the 8U2. Okay, so our what the processor. Okay, so again, Uno means one in Italian. So this just like in our country, in our local language, that is the same meaning to mark the upcoming release of Arduino 1.0, but instead it is called Uno, and there are released 2 and 3. So R2 and R3, and currently R2 3 is the latest model. Okay, for comparison with previous versions. Okay, so let us go further to summarize the specification of Arduino Uno R3 microcontroller. This is 80 mega 328. Okay, so very basic but still powerful when we are talking of connectivity or integration or controlling mechanical movement, mechanical motion, mechanical system. Okay, operating voltage 5 volts. Okay, input voltage 7 to 12 volts. Okay, and input volts limit Okay, 6 to 20 volts. So that is minimum to maximum. So that's why it's better for us to give it the an input voltage of 7 to 12. That is the optimum. Okay, and digital I/O pins 14, again of which 6 provide PWM output. Again, there is analog input pin. Actually, there are 6 of them. Okay. DC current per I/O pins, how much per 1 pin? So 40 milliamps per pin. So there are full I/O, so times 14, so 40 times 14, that is the total amount of amperes. So that is about 400 or 560 milliamps. Okay. DC current for 3.3 volts pin, so 50 milliamps. Okay. So plus memory, so 560 plus 50, so 610. So plus memory 32 KB, so kilobytes only, 80 mega 328. That is the microcontroller. Okay, of which 0.5 KB used by bootloader. Okay, dedicated as the bootloader. So meaning it would refresh and make the necessary initialization. Okay, so blank. So it will make itself as blank at initial. So preparation for its first time use. Okay? So bootloader, or every time it will what? It will bootloader, meaning this is the small program that tries to interpret and implement the program. Okay? So SRAM 2 KB, 80 mega 328, again inside the microcontroller. EEPROM, so EEPROM, electrically erasable. Electrically erasable. Okay. Programmable. Electrically erasable and programmable. So meaning to say, our program must be loaded at that IC, and that IC is still the 80 mega 328. So inside the same, so all of this is inside the 80 mega. So it's very powerful microcontroller. Plus memory, SRAM, EEPROM. Okay, all of those are inside the one IC. Okay, the 80 mega 328. Okay, clock speed again 16 megahertz. So schematic reference, we'll take a look much deeper on that. So later on we will have the diagram, the pinouts, and so on, the details of this. So power. Arduino Uno can be powered used via USB and external power supply. So V-in, okay, 5 volts, 3.3 volts, and ground. So those are the possibilities. The adapter can be connected by plugging a 2.1 mm center positive plug into the board's power jack. Okay, center power positive plug. So it is the usual shape of the DC voltage power supply power jack. So leads from the battery can be inserted in the Okay, it can be used, no? Leads, using leads, okay? Can be inserted in the ground and be in pin headers of the power connector. The board can operate on an external power supply of 6 to 20 volts again. So again, 7 to 12 is the recommended range. So for the 5 volts pin, these outputs are regulated 5 volts from the regulator on the board. There is a transistor type regulator device on board the Arduino Uno. Okay, so that regulate the supply of power. Okay, so the USB connector 5 volts or the voltage input pin on the board supplying voltage via the 5 volts or 3.3 volt pins bypasses the regulator and can damage your board. Okay, so it is not advisable. Take note of this. It could easily damage the board. Okay, okay, so very important to take note of this. Supplying voltage via the 5 volts or 3.3 volt pins. Okay, so because you can do it, okay, you can do it, doesn't mean it is recommended. Okay, if you do it, then you have to protect your controller. You have to protect it. Okay, so please take a look in our channel. We have the very simple example of electronic circuit that would protect this type of mistake. Okay, that would protect the board from damage by making such mistake of what, for example, reverse polarity. So please search for our tutorial video on how to make a simple reverse polarity circuit, okay? Protector. Okay? So how about 3.3 volt input generated by an onboard regulator? Okay, so maximum current draw is 50 milliamps. Important thing to know about that. Okay, there's a limit. So therefore, if your output is more than that, you need to control that load via relay, for example, static or mechanical relay. Okay, so memory. So the 80 mega 328 again has 32 KB memory with 0.5 KB used for bootloader. It also has 2 KB of SRAM and 1 KB of EEPROM, okay, which can be read and written with the EEPROM library. Okay, let's continue to input and output. Each of the digital pins on the Uno can be used as input or output using pin mode. Okay, pin mode function. So pin mode function, you can make a short program that would define the pin. Okay, if that pin is being used as input or output, you can define it in the program. Okay, so or on digital write function and digital read function. They operate at 5 volts. Okay, each pin can provide or receive a maximum of 40 milliamps. Okay, and has an internal pull-up resistor. So because it is now released or revision number 3, okay, so we have now this very good convenience. Disconnected by default of about 20 to 50 kilo ohms. Okay, pull-up resistor. In addition, some pins have specialized function. So take note, the pull-up resistor is internal. Okay, so serial type of communication, pin 0 RX and pin 1 TX, used to receive and transmit TTL serial data. Okay, so TTL level, so about 3.5 to 5 volts. These pins are connected to the corresponding pins of 80 mega. Okay, so serial USB to TTL serial chip. So this is what an upgrade from that revision number 2. For external interrupts 2 and 3, okay, these pins can be configured to trigger an interrupt on a low value arising on a falling edge or a change in value, since the attached interrupt function for details. I see the function. So we can use again the program to control to use this pin number 2 and number 3 as an interrupt. No, it could be used to trigger an interrupt. Okay, so that we can be alarmed, or the program can use whenever a low value arising falling edge or a change in value happens. What about pin 3, 5, 6, 9, 10, and 11? So there are 6 pins. We call it PWM pins. It provides 8-bit PWM output with the analog drive function. Again, directly all of these functions controllable with the use of programming functions. Okay. For pin number 10 and 11, 12, 13, SS, MOSI, MISO, and ECK, this pin support SPI communication using SPI library. So the SPI library, we have the complete details there. What are the definition of the pins and what level, what is the description, specification of the signals. Okay. And what about pin number 13, the LED? There is a built-in LED, okay, connected to digital pin 13. When the pin is high value, the LED is on. When the pin is low value, it is off. So can be used as a simple way to test if the IC, the microcontroller, is working properly. You can make a very simple program and do not need to connect anything. Just have an input and run it. Then you can control this pin number 13. Okay, and you can see the output LED with light or not. Okay. So the Uno has 6 analog inputs labeled A0 through A5. Each of which provide 10 bits of resolution, analog. So not only PWM but also analog inputs available, meaning 10 bits of resolution, 1024 different values could be discriminated by this input. Okay, so by default they measure from ground to 5 volts, so could be 0 to 5 volts and then divide by, take note, 1024. It's very good. It's very good resolution. Okay, very good resolution. 5 volts divided by 1024. It's very accurate when we are dealing with mechanical motion movement. Okay. By default, they measure from ground to 5 volts, and though it is possible to change the upper end of the range using RF pin and analog reference function. Okay. So TWI, so pin A4 or SDA pin, and A5 or SCL pin. It supports TWI communication using wire library. So another set of communication. Okay. There are a couple of other pins on the board. RF pins, meaning reference voltage for analog inputs. Okay. So we need to compare because we need to the signal to be calibrated. Okay, so comparing is a very important matter when we are initializing. Okay, so, and just manipulating the analog value. It's very important for us to have the reference voltage that we could rely on. Okay, reset button, bring this line low to reset the microcontroller. Typically used to add this reset button to shields which block the one on the board. Okay, we can also later on take a look at the map of the Arduino pins and 80 mega 3 to 8 ports. Okay, so communication. Okay, Arduino Uno has a number of facilities for communicating with a computer or other Arduino or another microcontroller could receive and transmit signal. The 80 mega 328 provides UIRT TTL, a 5 volt serial communication, which is available on digital pins 0 and 1, and also an 80 mega 16U2. Okay. On the board channel is this serial communication over USB, and so using the USB, okay, using the USB protocol, and appears as a virtual communication port to software on the computer. Okay, the 16U2. Okay. Firmware uses the standard USB COM drivers and no external driver is needed. Okay. However, on Windows, that INF file is required if we are using Windows. So, say just what? Communication protocol that uses something, file something. Okay. The Arduino software includes a serial monitor which allows simple textual data. Okay. Okay. So it allows simple textual data to be sent to and from the Arduino. It's very important capability. Okay. And the RX and TX LEDs on the board will flash when the data is being transmitted via the USB to serial chip and USB connection to the computer. Okay. A software serial library is available that allows for serial communication on any of the Uno's digital pins. Okay. The 80 mega 328 also supports I2C, TWI, and SPI communication. Arduino software includes wire library to simplify use of I2C bus. So that is the protocol, another communication protocol or standard. See the documentation for those details. We will look at it later on. Okay, so more on available support library. So for the programming of the Arduino Uno, we can use Arduino software that is free to be downloaded. Okay, you just have to select Arduino Uno from the tools. Okay, for details, we will also explain this basic form of programming the Arduino Uno. The 80 mega 328 on the Arduino Uno comes pre-born with a bootloader, so we don't need to do it on our own. So it is also already there. Okay, So again, that is 0.5 of memory. That is already the simple way to control all the coming series of instruction. Okay, so we don't need, therefore we don't need any use of external hardware programming. So I am the one who came from the older generation, which encountered several hardware to be prepared when we are doing the development of the system. Example, IDE, you need to prepare a programmer or room burner, no? Or room burner. So there are several circuits that you need to prepare. For example, it is same with what? With, for example, civil engineering. If you will make a building, you need a foundation. But you cannot see the foundation. You cannot see the foundation. It's under the ground. You know it is underground and supports. It supports your building, but you cannot see it. There is no other. There is no other function just to support the ground. It supports the ground without even giving us additional advantage. Okay, but it is very critical because it is a foundation that supports the whole building's load. Okay, now another thing is the pulse work and form works. We need to put up several wood form works in order to cast a wet concrete up to a certain day that the concrete would be hard enough so that we can now take off all the formworks. So formwork is another example of those hardwares that are really necessary, okay? But they do not have function when you are using the building. Actually, after its use, there's no waste. No? We do not have any additional use for the pulse work, for the formworks. Okay? So the same is true with this external hardware, burner, from eraser. Okay, so after you uploaded the necessary bootloader, uploaded the program, the microcontroller, so any other accessory devices are now not necessary. Okay? So that is very good. Here is that the Arduino Uno already have a pre-born bootloader, so it's very convenient. Okay, for example, you don't need to put up the pulse work. It's already there. You just have to do the mixing of the concrete and put it on the prepared pulse work. That is the analogy. Okay? So very convenient nowadays. In our time, you have to do so many things at each and every step, very hard. Now, engineers also prepared and could easily learn these things and could easily try out these things. Okay? You can also bypass the bootloader and program the microcontroller to the ICSP in circuit programming. Okay, so there is a provision. Okay, so we have a C header files, meaning this Arduino board is using C language. It could use C language because of this. Okay? The 80 mega 16U2 or 8U2 in the revision 1 and revision 2 boards, firmware source code is available also. The 80 mega 16U2 8U2 is loaded with DFU bootloader, which can be activated by this these one boards connecting the solder jumper on the back of the board. Okay, you just have to connect the solder jumper on the back of the board. There the map of Italy, and then resetting the 8U2. On revision 2, however, or later boards, there is a resistor that pull the 8U2, 16U2 hardware board line to ground, okay, making it easier to put into the FU mode. Okay. So another convenient way they designed it, easier, okay, easy to use. Okay. You can then use Atmel's Flip software if you are using Windows, and meaning you are using Windows for your interface development environment. Okay. To load a new firmware, or you can use ISP header with an external programmer overwriting the DFU bootloader. So you can even overwrite the DFU bootloader, okay? But that is very critical. Do not do it unless you know what you are doing. Okay, when you do it, do not do anything like that. Do not touch the bootloaders unless you are sure what you are doing. Okay. So automatic software reset is also on the board. Okay. So this automatic software reset, okay, rather than requiring physical press of a reset button before upload, the Arduino Uno is designed in a way that allows it to be reset by software running on connected computer because of communication, so using that USB RxTX pins. Okay. So next, USB overcurrent protection. Okay. So Arduino Uno is a resettable polyfuse that protects your computer's USB ports from shorts and overcurrent. Although most computers provide their own internal protection, the fuse provides an extra layer of protection. So if more than 500 milliamps is applied to the USB port, the fuse will automatically break the connection until the short or overload is removed. So you need to replace the fuse, okay, or reset the fuse. Okay, so the fuse is resettable. Okay, resettable. So, but if you don't know how to reset it, so since it is break after being broken by the overcurrent, so you cannot use it. So you need to know how it is being reset. So there is another, then we can talk about it in the later videos, okay? Because we need a special video for that discussion, and we may need the actual exhibit or the actual demo. Okay. Physical characteristic, maximum length and width of Uno PCB are 2.7 and 2.1 inches. Okay, 2.7 by 2.1. So it is not very long. 2.7 is about this one. So 2.1 about this one. So in that is about what? is about 50 mm to 66 mm. So that is about the dimension of so about 55 mm by 670 mm. So that is about the very small, no? Very small board. Okay, so very small piece of board. Okay, there are available holes for screw. Okay, so that it could be attached to a surface or case. Note that the distance between digital pins 7 and 8 is 160 mil or 0.16 inches. Not an even multiple of the 100 mil spacing of the other pins. So it is wider. Pin 7 and 8 is wider. Physical. So it is being explained so that you must not misinterpret that design as mistake. Okay, you may misinterpret it as mistake. Okay, so pin 7 and 8. This one, pin 7 and pin 8. So there is a bigger discrepancy. Okay, 160 mils. The normal distance is 100 mils. Okay, so that is to be expected. So don't misinterpret this as mistake in production. Okay, so any questions? I may give you some time. So see you on the next live video. Thank you.